Hi, I am currently Patindol, Section A1, Set 7, Chemistry for Engineers. Today I will be showing you the solutions to the questions. Number 1. The potassium is 227 picometer in radius, and we are tasked to find the edge length of the unit cell. I use the Pythagorean theorem in finding the edge length of the unit cell. So, I derive this, or I get the formula, which is d squared plus d square root of 2 squared is equals to 4r squared. So how did I get it? So here in the below, I draw the unit cell or the cubic unit cell. Then here, this is what we are tasked to get. Then I found out that the sum here is d square root of 2 for the leg, and the hypotenuse, which is the longest side or length, is 4r or 4 radius. Then I plug in the answers. I plug in the values to get the edge length of the unit cell. Then first I get the 4r and substitute the radius of potassium, which is 227 picometer. Then I got the value 908 picometer. Then I insert the value 908 picometer. I squared it and the other two as well, which is the legs. So I got here 3d squared, which is d squared. Then the square root of 2 is 2. Then I am left with 2d squared. So there is this same variable. Then I just add it directly, which is 3d squared. Then I first get the square root of 908. Then I have 464 picometer. Then divided by 3, I have 821.33 picometer. Then the last step is to square root, or to add the square root of both d squared and 274,821.33 picometer to get the final answer. Then I have 524 picometer is the edge length of the unit cell. Number 2. So in question number 2, I am tasked to find the osmotic pressure. So we're given with the temperature, the density, and the liter. So the formula for osmotic pressure is OP, which is osmotic pressure, is equals to the temperature times the R, which is the constant, and the molarity. So first, we need to convert the Celsius into Kelvin, and I have 297.08 Kelvin. And the R, we know that 0.08206 liter ATM per mole of Kelvin. The molarity, we are given the mass, which is 37.5 milliliter. Then I convert it into grams. I got 0.0375 grams divided by the density, which is 1.503104 grams per mole, and divide it again with 0.025 liter, which I got for converting 25 ml to liter. And I have the value 1 mole per liter for it. I insert the values, those values, and I have 24, or I get 24.38 atm for the osmotic pressure. So in number 3, the question is, why don't soap micelles coagulate and form large globules? Is soap more effective in fresh water or in seawater? So in question 4.3, the first part is, the reason for it is that the structure of the soap is in spherical shape. Here, this is the structure of the soap. Then the small circles here is polar. Then the tails is non-polar. So here, this head is a hydrophilic, and this tail is a hydrophobic, which is fear in water. So when we know that the polar and polar heads connect each other, or kanang mo kuan sila compatible to form solutions. So iyang kuan sa molecules sa soap, which is ang same ends to do not coagulate, which is katong head, and the polar ay katong same ends, which is katong sa tails, kay dili sila mo coagulate, and the polar heads don't join. Mo na reason ana sa number 3 part 1. So sa part 2 is soap more effective in freshwater and seawater. So as you add salt water, for example, you affect the properties of soap in a lot. So pure water is not as effective with soap as water with a small amount of salt. So as you increase the salt concentration even further, complex things happened with the soap, and it can become less effective. So in conclusion, so soap is more effective than fresh water. Like for example, we are taking a bath using tap water or fresh water, than compared to the salt water, which when we go to the sea, then we took a bath and put soap on our body, the moisture won't go away. So water is effective than sea water. So in question number 4, what give one topic from module 2 that you have learned the most. Why did you choose this topic? So the topic that I like the most is topic 5, which is gases. So I learned that gases has high compressibility, low density, and I learned that there are many laws applicable for getting the pressure, volume, and the temperature of gases. One is the Boyle's law, which is the constant is the temperature, and in Charles' law, the constant is volume. And Avogadro's law is the constant is the pressure. Then those three combine into one, we form the ideal gas law, which is the formula is PV is equals to N, R as the constant, and that T is temperature. And I like it because I don't know that gases would be able to form liquid and solid, which is nice. Thank you.